Hello? Awesome. Can you guys hear me?
Yep.
Yeah.
Awesome. All right, guys, let's begin. Hi, everyone. This is the second workshop for the AI team, which is part of the Google Developer Student Club. And today we will be going over Scikit-Learn. So, what is Scikit-Learn? It is a very popular library that provides supervised learning and unsupervised learning algorithms that we can use to um, make visualizations and trends from data. So yeah, for those of you who were here last week, you guys probably know what supervised learning and unsupervised learning are. We will be doing a recap in the next slide, but we're basically making visualizations and establishing trends from given data using these set algorithms, and the Scikit-Learn is a library for that. So we have some useful libraries such as NumPys, Pandas, and Matplotlib. These are some of the most commonly used libraries that developers and coders use alike to to build such models and visualizations for these models. And up above, we have a small code segment that has the importing and of such an implementation of such libraries. So models that are part of Scikit-Learn include regression, classification, clustering, pre-processing. We will be going over regression and classification today, and clustering will be for future workshops. Awesome. So moving forward. So just to recap what supervised learning is, supervised learning is a machine learning approach that is defined by its use of labeled data sets. So we essentially have data and we have labels, or we have ways of we have essentially established output, and what we and I guess like with the data, we try to make we try to predict, or like the computer tries to predict. It tries to make predictions based off of the information that's been provided to it. So there is a way for the computer to make reasonable deductions. So from the example that we have here, if we have we have pictures of chickens, cats, and dogs, and the computer will learn that each of those are a chicken, cat, and dog. And then when given a set of animals, it'll try to predict what is a chicken, what's a cat, what's a dog. So that's an example of supervised learning. And we're going to be focusing on two of some of the most important models that anyone should ever need to know for supervised learning. So let's begin with regression. So regression is a supervised learning example, and it's used to predict an output that consists of one or more continuous variables. So if we look down in the graph below, we see a two-dimensional data set with principal components, and we're trying to establish a relation. So y versus x, or in this case, we're trying to establish the relationship between two features, and we're trying to establish in this particular case, we're trying to establish a linear relationship, and this is known as linear regression, which is what we will be focusing on today in today's workshop. But it is a continuous relationship, and yeah, that's pretty much what you can see in the graph. So next we move on to classification. This is also an example of supervised learning. The goal is to take in sample data that has labels and then classify those labels to unlabeled data. So pretty much, pretty much just the same example as I talked before, where we had labeled different animals as chickens, cats, and dogs. And then up above, we have a very popular digits data set where the computer takes in pixelated pictures of digits and tries to assign them to the correct labels, which are like 0, 1, 2, 3, all the way up to 9. We can see some of the predictions up there. And one main difference between this as opposed to regression is that it is discrete as opposed to continuous, which just means that we just have like a finite number of labels and finite number of outcomes, as opposed to regression, which has like a continuous kind of output. We don't, as is obvious for classification, we have labels that are like 0s, 1, 2, 3, just like well-defined labels. We don't have I mean, we don't have like millions and millions of different labels. So it makes classification really easy. So yeah, this is about the only theory that we will be discussing in today's workshop. So we're going to be, this is just like important for you guys to understand what we're doing and why we want to learn more about regression and classification. And for today's workshop, we will actually be doing some interactive coding with you guys, where we're trying to get you guys to learn about how to build your own models. And so we will be coding. So we will be asking you guys to build your own regression models today. So first, I'm gonna ask you guys to open Discord, because we have put a link to, oh, never mind. I think the link is right here. Yeah, so if you guys can just like copy this link, and does this take you? Yep. Yeah, I'll toss this in the Zoom chat for you guys as well. So this takes them to the notebook. Yeah.
Please put it a thumbs up or something in the chat.
Yeah, so if you guys are able to open this notebook, it should look something like, it should look exactly like this. Yep, so has everyone been able to open the notebook?
Can you go back to the link just for 1 second?
Yep, just give me 1 second. Let me move this back.
All right, got it. Thanks.
Yep. Awesome. So if everyone is able to, where's this notebook? Yeah. Awesome. So if everyone's able to open this notebook, we're gonna first ask that you guys make a copy of the notebook so that you guys can make changes, and then you can have your changes to yourself. How do you?
Just
File. Okay.
Make a
Yes, you just. Yep.
Save a copy in Drive or save a copy in whatever they want to do.
Yep. So you guys just save a copy wherever you want to, and then you can work from there. So just just like in the group chat, for those of you in Zoom, if you could just just give me like a thumbs up or or just a confirmation that you guys have a working copy up and running. When you've got it, that would be helpful. Does everyone have a copy?
Yep.
Awesome. All right. Well, if everyone has a copy, then we can begin. So we have a notebook, which is a set of cells that have codes of Python that you guys are gonna code up and write yourselves. And what we will be doing today is we have different parts in the notebook. We have subparts, just smaller tasks for you guys to do. And so what we will be doing today is we will be going through each individual part, and after a given amount of time, we will move on to the next part. And so we'll give you some time to complete the tasks at hand, and we will assist you in any way that you need. And for the most part, we didn't want it to be like a class where we like teach you kind of like where we teach you like the individual functions and all the code that you guys are gonna have to run. We kind of want you guys to like go online and just kind of figure it out yourself. But if you do need any help at any point in time, feel free to reach out and we can give you a hand. So we'll give you guys around 5 minutes to kind of like figure out how to do the first set of tasks. It's relatively straightforward. We're just importing. So the task at hand, I'm sorry, I forgot to mention that, but the task at hand is essentially we're taking in data from this website. So I'll just go ahead and show you guys what we got in there. So this is data that is given to us, and we essentially have for the given dates, we have the number of COVID cases and COVID deaths that have occurred up till this point in time. And what we're trying to do today is we're trying to build a regression model to kind of showcase the relationship between the number of deaths and cases. That way in the future, we can predict the number of deaths per given number of cases. Yeah, so we have the different states as well. And for today, we will be trying to predict the number of, we're trying to establish a relationship between the number of deaths and the number of COVID cases here in Minnesota. So we have a wide variety of states, but we'll only be focusing on one. So that is the task, or that is the overall part of the overall task in our project. For right now, I'm gonna give you guys like 5 minutes to kind of figure out how to do the first set of tasks. Relatively straightforward. We import data into a data frame from this given link, and then we just do these 3 small mini tasks: print out the first 5 rows, print out the maximum date, and print out the number of columns and rows of the data frame. Yep, and it's a pandas data frame. Yep, so 6:23, we will get back. But if you guys need any help, just like, I mean, for those of you in Zoom, you're more than free to unmute yourselves, or if you prefer, you can just like raise your hand or type in something in the chat and we can give you a hand. Yep. Also, when you guys are done, just like put a thumbs up in the Zoom chat for those of you in Zoom. Awesome. All right. Well, I think that's about enough time for that. Do you guys think, to those of you in Zoom, do you guys think you have a good handle on how to solve this? We'll be going into solutions, but if you would like some extra time, I'd be more than happy to give you that. Okay.
For anybody who's stuck, they can always ask questions on the how to proceed.
Okay.
Ask them like how did they try solving it and what functions they tried using.
Okay. Awesome. So if anyone's completed it, I'd love to hear some of your solutions before we delve into into our own solutions. Yeah, you guys can screen share if you want to too.
She cannot. I mean, she can tell what functions they are. You can just.
Yeah, you just have to use pd.read CSV for the first one, then you use the head and max, and you have shape.
Awesome. So yeah, we got the answers from one of our students here. So we begin with to import the data, we do a pd.read CSV read CSV function, which let's see. Oh, yep. So we got a pd.read CSV, which reads the data from this CSV file into a data frame. And then to get the first 5 rows, we use the head command, which by default prints out just the first 5 rows, but you can manipulate it to your liking. You can print as many as you want by just simply writing the number of rows that you want to read within the parentheses, but we're just going for the 5. And to print out the maximum date, we use the date.max, just another small function that accomplishes our goal. And then we have the df.shape, which prints out the number of rows and columns. So that gives you the number of entries and the number of features that are in your data set. So these are just like some extremely basic functions. And the reason we bring these up is just to get like a basic understanding of some of the information in your data. For the most, sometimes you might not be able to open your data, and to kind of get like a good idea of what is in there. These are some of the really basic functions that could definitely be of assistance in providing you information. Well, awesome. So if no one does anyone have any questions? I will take that as a no. And awesome. So that's our very first step. So now we have our data loaded into the data frame. And now we're ready to move on to performing some basic tasks and then providing some visuals on what we got. So just moving on to part 2, we will now go into part 1. So the goal here is to we're trying to filter rows using one, so just using one specific column, and then we're trying to plot a graph for the given data. So essentially the task at hand is we want to plot the number of deaths versus the number of cases on a specific date. So this is 5/1/2020, that is May 1st, 2020. So if we go back to our raw data, where is the raw data? Yeah, so if we go back to the raw data, we see that for any given date, there are multiple states that have cases and deaths listed, and we're essentially trying to plot the total number of cases versus deaths for all of these states combined on a given date. And that is the goal of our part 2, subpart 1. So we have 3 different tasks down here. So we want to filter and keep the entries that we care about, and we want to store the filtered information in a new data frame. Then we want to plot a death versus cases scatter plot, and then we want to annotate every point with the name of the state. So yeah, this is a useful link for anyone who feels like this is just a starting point for you guys to take a look at for the filtering. Yeah, so I'll give you guys an extra maybe like 7-8 minutes. So let's meet back at 6:36. Yeah, if you guys have any questions, feel free to message in the chat. Yeah, and when you guys are done, just I don't know, just like put something in the chat so we know that you guys are ready to go. Because I don't want to proceed if you guys aren't feeling comfortable with what you have so far.
Are you talking because your microphone is muted?
Oh, wait, now, wait. Oh, wait, now can you guys hear me?
Yes.
Okay, my bad. Yeah, I didn't even realize. Sorry. So I'm assuming that were you guys able to hear me from like subpart 1, or has it been muted for a long time now?
No, it's like when you let us work, like you muted and then you didn't unmute since.
Oh, from subpart 1 then?
No, for subpart
Oh,
2.
from this.
Yeah.
Okay, awesome. Okay, awesome. So yeah, so as I was just saying, all of the yeah, let me just hide this first. Yeah, so as I was so the first thing I said was that like all of these answers we will be posted later on. So if you feel like you didn't have much time to go over the answers, we'll have them later on for you guys to take a longer look at. But yeah, so the first task at hand was to filter only the entries corresponding to this specific date. And so the way we did that was we search up, so we open our data frame and we search up for the entries. We're searching up only for those entries that have this specific date value. We don't care about any of the other dates. And obviously the conditions that you can put, the conditions that you can put inside vary, so you can like search for, you can search for only those entries that are part of, that might be relevant for a specific state or for a specific number of cases, whatever you want. For us, for this specific task, we only care about these dates. But this is the way to kind of like filter out the results that you care about. So that is what's happening here. For the second task at hand, we are we're plotting the deaths versus cases scatter plot for every state, and then we want to annotate every point with the name of the state. So what this means is if we have, this entire function that you see over here is a plotting function, and in the plotting function, all you have to do is just specify your x and y values, and this is kind of what the graph looks like. All you got to do is specify your x and y values, which are the cases and deaths. So these are the column names or the feature names that, or the column, yeah. So the column names are feature names that are part of this specific data frame. So that's so all you need to do to specify what the x and y values are is to just list out the column names, or the column names that you care about. And then kind equals scattered, you can just specify whatever kind of plot you want. For our purposes, we've specified a scatter plot. And the fig size is just your figure size. And as you can see, we got the title, which is deaths versus cases on this specific date. For the annotation, so if we didn't apply an annotation, we would just get dots over here that don't have any names on them. So we have applied this. So we applied this lambda function, which is essentially we go through the cases. So we go through every entry in the data frame, and then we take out the state label, and that is what is displayed. So we only care about the state label. So that's what's going on here. The dot apply function applies this lambda function, which is essentially just rotating, which is essentially going through the rows and just pulling out the state values that we care about. So that's what's going on here. Relatively straightforward. You can take a look at it later if you feel like you don't understand. Or you could always shoot us a text later, or if you have any questions about this right now, you guys can ask me right away. Does anyone have any questions? Okay, I'll take that as a no. Yeah, so we can move on to the next part. So in the interest of time, we'll be speeding up a little. So the next two subparts are kind of similar to subpart 1, so it's not very different. So I'm just gonna, so for subpart 2, even though there seem to be a lot of tasks, as you can see over here, the second set of this entire second code block is the same as the first code block. So so you guys, so it shouldn't take too much time. And this code block over here is only 2 minutes, or it shouldn't take very long. Yeah, so you guys have, I think I'm just gonna give you guys like 4 minutes to work on this real quick. I'll have the answer slides up as well. So if you guys didn't have time to finish your previous subparts, you can work on those right now. But yeah, so you guys, I'll unmute myself at like 6:48. So in the interest of time, we will be continuing. How do you, to those of you in Zoom, how do you guys feel about this? Do you have any questions, any concerns on subpart 2? Okay, I'll take that as a no, and we can continue. So the filter, so we start with the first task, which is filtering, so that we keep the entries that do not have the state as New York or New Jersey. We don't care about these two. So it's pretty much the same as what we did before. Instead of an equals equals, we have a not equals, and we're chaining the not equals with an and. So pretty straightforward. And then we're displaying the first five. We're displaying the first five entries in the data frame. So yeah, very as you can see, we don't have any New York or New Jersey entries. So pretty straightforward. And the remainder, we're probably not going to go into this because it's the same as the previous case. And the only reason we don't care, we're skipping the New York and New Jersey states are because if you look at the graph, the first graph that we made, we see that New Jersey and New York are like extreme or outliers. They kind of skew the number of deaths versus cases. And yeah, it relatively messes up the data and doesn't provide us an accurate representation. So if we look at this, if we look at the graph down here, without New York and New Jersey, it looks a lot more, I guess, neater, a lot more safer, I guess. Less cases, less deaths, more humane. Yeah, so that is it for subpart 2. So subpart 3 is again just more manipulation, which is more it's just a way of like visualizing and plotting graphs. We're not going to do that right now. We're probably going to move on to the next task, the most important one. So this is just more of a sub exercise that you guys can do on your own time and kind of like check your answers with our a set of answer slides later. But yeah, if you guys do end up doing this, and if you ever want, if you need any help, just reach out to us on Discord. So we're gonna move on to part 3. This is the actual machine learning part. I would say this is the logistic regression. This is what this entire work, the notebook, or I guess the project is designed around. And, oh yeah, just before we proceed on to that, we have a commented code block here, and this code block essentially, if you uncommented and if you were to run it, you would get this graph, which essentially shows you the number of cases or number of deaths versus number of cases for all the 50 plus different states that we have. And as mentioned earlier, we're only focusing on one specific. We're trying to establish a logistic regression model for one state because, as you can imagine, there's probably 50 different trends for all the different states, and we can try to generalize the trends of deaths versus cases for all of these states, but it would be a little complicated. But it can be achieved. For those of you who are interested, it can be achieved through a method called one-hot encoding. You guys can definitely take a look at that if you're interested. But for the purposes of our workshop, we're only concerned about one state, and that is the state we live in, Minnesota. So let's move on to part 3. So subpart 1. So before we so right here we were in subpart 1. The goal of the subpart 1 is to first filter the data that we care about. So just only the entries in Minnesota. Then we want to plot a case. We want to plot a cases versus deaths graph to just kind of understand, okay, like what the plot looks like and what kind of information it's giving us right now. And then we get to the most important part, which is splitting the cases of deaths into training and testing data. So I'll just get back to the slides to talk about this for a second. For those of you who don't know what this is, went a little too far. So training and testing data. So this is very important for any machine learning model. This is the way that we're able to assess how accurate our model is and whether it's working at all. So essentially, when you're given data and we choose to apply a data model to it, we first split the data that we're given into training and testing data. Training data is data that has meaningful relations and essentially has all the kind of has like all the answers given to us to the computer, and the computer tries to learn from that data and try to make predictions off of the data for the future. So in the earlier mentioned example where we have or like, I guess in this example, training data would essentially be data where, or like entries where we know what the number of deaths are for a given number of cases on a specific date. That would be training data. Testing data is when the computer is able to make a meaningful relation, is the data that is tested against the predictions that a computer, or that the computer makes once it has taken in the training data. So based off of the predictions that it has been given, the computer tries to make predictions, and those predictions are tested with against the testing data to determine the accuracy of a given model. So as we see right here in this example, as we see in the example down here, we split the training data into training data and validation data, and we have the testing data as well to confirm the accuracy of our data model once it's done making predictions. So that is why training and testing data is pretty important. And so for our purposes today, it's lagging. Give me 1 second. Lagging a little. Okay. Yeah, there we go. Yeah, so for our purposes today, we want to have training and testing data for the entries that we have. So for the entries that we have here from our data, or for the entries that we have that are in Minnesota. And it is accomplished using the train test split function, which is part of Scikit-Learn. So I'll give you guys like another 3-4 minutes to take a look at it. So 6:58 we'll get back. But train test split is, you can look up the documentation online on the official Scikit website, and you should be able to get a minimal understanding of how to apply it. We'll meet back at 6:58. So are you guys, does anyone have any questions, any concerns? All right, if anyone, if no one has anything, we can continue. So this is the train test split documentation, and we have the X and Y, which are, and our X, so our X is the number of cases, the Y is the number of debts. So that's those are the two quantities that we're trying to establish, or the variables that we're trying to establish a relationship between. So let's see. Yep. So we filter out the results. So the filtering is the same as what we did before. We filter out the results that we care about. These are the we filter out the results that are in Minnesota, and then then to plot the graph. We use the matplotlib, so PLT. You can look up the documentation online, but essentially it's a library dedicated to plotting graphs, as we see down here. And this graph down here is the graph between the number of cases versus the number of debts. And so we see that it's not necessarily linear, and it's a weird curve, but that's what it looks like. This is the graph that we're trying to model we're trying to predict a linear fit for. So this is the graph. This is like the actual graph. This is the actual graph, pretty much, with the actual values. And so we just assign X and Y to, so the X and Y, our X is DF of case, or is the number of cases, Y is the number of debts, and those are the values that are assigned to our train test split model. And for the train test split function, we have a test size that that splits that splits it into the split that we want. So this is a 30-70 split, but you could split it however you want to. You might just get you might get slightly different values, but in the end, it all works out. The difference should be marginal at best. So on top, so we also have two lines of code here that the np.new axis. So this is more for what comes on later, for a function that we're going to be applying later. So this just so right now, our X train and Y train are both just vectors that are vectors in one dimension. But we want but the computer doesn't know that it has one dimension.
You want to convert that to a matrix, to n+1 matrix.
Do you want to?
Sure. So essentially, one thing you can understand is that the X train right now is a one-dimensional vector. So it'll have something like a 600 rows or something like that, which typically means it's one-dimensional. But the thing is, for most of the calculations you have, you'd need a matrix. So essentially, what this new axis does is adds an additional dimension to whatever you have. For example, if you give it a 2D matrix and add this new axis, it'll make it a 3D matrix. If you give it a 3D matrix, add one more axis, it'll make it a 4D matrix. In the similar manner, when you give it a vector and you do a new axis, it ends up making an n×1 matrix, which is what you'd be using. Any questions on this?
Thank you, Arvind. So yeah, we're doing this so that we don't end up, so that we can use one of our functions that comes down the line without any issues. So I realize we've gone a bit over time. We'll be wrapping up soon. So we're just gonna quickly run through the last couple of tasks and we shall be done. So I'm gonna kind of group together subparts 2 and 3. They're pretty much the same. They should be together. I just kind of grouped them apart for easier understanding. But subpart 2 is performing linear regression using the linear regression function from Scikit-Learn, and subpart 3 is essentially just getting our predicted values and then trying to see how accurate our model is, how accurate our linear regression model is to the actual values. So I'll give you guys like 5 more minutes. If you guys have to drop, that's fine. We have all of this is being recorded. You guys can take a look at it later. But yeah, so we got 5 more minutes. 7:08, we will regroup. Thank you. All right, we will be continuing. So our first task was to perform linear regression using the linear regression function from Scikit-Learn. So let's take a look. What do we have? So we have, we import linear regression, and then we use the .fid function, which essentially produces an equation, which we see down here. This is the equation that it gives us. This is the computer's version of, okay, like what is the relationship between debts and cases? This is the relationship. So we have a intercept and we have a slope, and you can graph the line. We will be graphing it. We'll be graphing it in a second. I'll pull that out. But this is what the equation. This is the linear regression relation that has been that the computer's decided is correct. You can this error is just a formatting error. It's no big deal. We'll fix it and give it to you guys. But essentially, what's going on here is we're just getting rid of the intercepts because, like, obviously, if there are 0 cases, there should be 0 debts. But which is pretty straightforward. But like, this isn't the case with this equation. So all this line of code is doing is just getting rid of the intercept and just making it so that we have just a coefficient and a coefficient so that we have a number of debts for a number of cases. So the next task at hand was to create a new column in your data frame that has the predicted value of debts so that you can compare that with the actual debts and also get the errors between the two. And so let's see. So the adding a new column is pretty straightforward. You just we just create a new column, predicted debts, and then you assign that. And then to get the predicted debts, we take the number of cases and from the data frame, and then we use a lambda function, which essentially maps this formula, which is the linear regression model that we just got. We're just applying that linear regression model onto the linear relation. We apply that onto the number of cases to predict the number of debts. And we use the mean squared error to calculate the mean square error. It's a function that you can import from Scikit-Learn. And RMSE is the root mean square error, and it's simply the square root of the mean square error, so pretty straightforward. And then for the last part, we're essentially we're plotting the graphs between the number of debts and the number of predicted debts. So we first create AX. So this line of code right here creates a common axis for both of our graphs, and essentially, that's weird. I thought this would be running, but unfortunately not. Give me a second, folks. Yep, there we go. We got our graph down there. So we're essentially, we see here, this is the relation. This is the blue line predicts the actual debts, and the red line is the predicted debts. This is what the computer has predicted. This is the predicted linear regression model, and we see that this is the line of best fit. This is what we're trying to go for, and essentially that's what these last 3 lines of code are doing. We are creating a common axis for both of these graphs, and these last 2 lines are used to graph the debts and the predicted debts. So yeah, this is kind of like what we're going for at the end of the day. We're trying to, this is the model, and we can see that for the most part, it's pretty accurate to a certain degree. But yeah, this is the end result, and that's the end of our workshop. So congratulations to you guys. You guys have built your first linear regression model. So we're just going to go back to the slides real quick, give you a couple of heads up about the next workshops, and we're ready to wrap up. Awesome. So upcoming workshops. So there's a second part to Scikit-Learn where we will be talking about classification, clustering, other models that will definitely be of use to you guys. And then, as always, we have TensorFlow, CNN, reinforcement learning, and future workshops. So yeah, definitely stay tuned for that, you guys. Yep, thanks for coming, everyone. So this is the Google development, this is the GDSC's upcoming timetable. So yep, we'll have our president.
Also, so next week on Wednesday, we have a cloud study jam. So we'll make you guys go through some of the quick labs courses provided by Google. And if you join us for the event, you'll also get access to the quick labs platform courses and quests for free for 30 days. So do join us to get like the basic understanding and hands-on opportunity to explore the Google Cloud Study Jam platform. Yep.
Also, our next Android workshop is going to be a hands-on app building workshop. We'll be doing intro to Flutter, and we'll be learning that by starting to build an app together.
Yep. So do join us next week on Wednesday for the Cloud Study Jam and on Thursday for our Flutter workshop. And thank you for joining us today.
Yep. Thank you, everyone. If you guys got any questions, our officers will always be on Discord to answer them. So yeah, definitely shoot us a message if you need any help. We will be posting our slide. We'll give you guys the link to our answer slides soon, and you guys can also take a look at the recording for of today's workshop when we get it up and running. So we'll let you guys know about that. But yeah, thank you for coming today. Have a great week. Survive midterms, everyone. That's about it for today. All right. See you guys. Bye-bye.